It's 3:30. Excellent. I am kind of curious, how many of you don't like AI? I mean, I don't really care. I'm just kind of, somebody had said that, I don't know, one of my classes, people were complaining because I talk about AI in class and they don't like it. So it made me curious, how many people, so a couple of you say you're ambivalent. Why?
I mean, I just feel like, I'm like fine with AI. I don't like dislike it. I just feel like it's taking away from someone's own learning, I guess, in terms of like.
When I actually share that concern, am I doing these kind of crazy things like having you sign commits and whatnot? If I could, I'd actually have your AI sign commits with a different key. That's what I do with my own key, my own code, and I have a very concrete reason for that, which is that if I'm going to claim that I own something, it can't be generated by AI, because right now the state of the law says that AI can't generate something that is eligible for copyright or patent. So I watch Google talking about AlphaFold, the protein folding tool, and I'm going, you guys are patenting this. The patents are not going to be valid because they have publicly said these were developed by AI, and AI can't be, they literally are not allowed to patent it. And I think what they're going to try and do is they're going to come back and they're going to say, well, you know, there was some human involvement. And my observation is, great, prove to me how much there was. And this is where signing things becomes important. Because if the human was actually involved, then let them sign the work with their own actual signature. And if you aren't doing that, and it's easy to do, and it is easy to do, then a court can reasonably infer that you didn't keep the records because it was inconvenient for you to not keep them. So it creates a kind of affirmative responsibility for that. So I think that that is a very important concern. The idea that people are looking at AI as oracles, that things that can give them answers. And the problem is that AI give you the confident answers. Do you have a friend who always knows the answer to everything? Or someone that you know who's always completely convinced that they know everything and they give you their answers and they sound very convincing about it, and then later you find out that it's bullshit? There you go! That's AI. It's fascinating to see what has actually been built there. At the same time, what I also find is that if I really want to have a cross-disciplinary conversation where I actively want to explore multiple ideas, it's hard to find almost any other human being who will combine some of the crazy stuff that I combine, where I'm sitting there talking about distributed systems and 1960s computer architecture and, large language models. But they can't do that. But I don't believe them any more than I would believe you. And I think that's the hard part here. There's also the existential threat part, which I was curious if people feel pressured because they're being told that AI is going to take away everybody's jobs. It could be done that way. That is an option. But that's a social decision. It's not a technical decision either. And sometimes it's hard to tease those things apart. I'm trying to find a balance to give people a reasonable set of skills for dealing with AI and using it in a constructive way. But to do that, you can't treat it as an oracle. To do that, you have to actually say, what you just gave me turns out not to be true. That's why I wanted you to keep an AI log. Literally to say, oh, I talked to Gemini, and Gemini gave me this whole beautiful story. I went and actually tried it, and it turned out it was wrong. To me, that says you are reasonably using it and not trusting it. You're validating the information it's giving you in a way that establishes proper critical thinking. If, on the other hand, you go to ChatGPT and it gives you some very bullshitty kind of long answer and you say, oh, well, this must be true because ChatGPT said so, and it sounded like it knew what it was talking about, then you're failing to do exactly that. You're not questioning it. You're not saying, I don't really trust this. An idea that's come out of some of the research I'm doing recently. While I was testing this in Cloud Code thing, I actually ran through the proxy server while doing this, and I found a bug and then fixed that in the proxy server. I said, if I wanted to have a service that would take a claim and set of proof and build a package that had an independent attestation, in essence saying this claim and this proof was presented to me at this time in a way that was forge resistant. So it puts the data on a blockchain, it uses information, and it records it in a way that someone else can later look at this and say, okay, that is what you actually did. This is important in exactly this instance where now we have agentic AI, which are trying to engage with people. And I said, well, how do you actually know when they've agreed to something? How do you know when what the contract is, what the transaction is? And this provides you with a way of establishing a transactional verification service. That's a cloud service. That is a literal cloud service just waiting to happen. You give people an API, they can send evidence to it, they can pay extra if they want someone to go independently validate the claim, because that becomes an extra attestation. And the obvious case there would be for lawyers, because lawyers have been getting into trouble because they've been taking citations from ChatGPT and using them as if they were real, and they're not. And so now you have a wonderful business model where you can actually say, look, you're a law firm, here's an API service, you put it into your workflow, you use credits each time, you check each time you pull a citation, make sure that it's attested, you add that attestation, you get to a point where courts say this is great because this is independently verifiable. Even, and this is part of the design, even if this company goes out of business, these packages contain everything that's needed in order to verify the claim at the time it was made. Maybe things change. Maybe somebody, papers are a good example. Maybe a paper gets withdrawn, retracted. That doesn't mean that the claim that you made before the retraction is wrong. It just merely means that you relied upon it, and now someone can easily say, this is no longer a reliable claim, but it was at the time it was made. When I do expert witness work, what I'm saying is, based upon the evidence in front of me, this is what I have concluded and why. And that's kind of what I'm talking about. Build that as a cloud service. Simple API, database. You use existing blockchain mechanisms to tie yourself to the blockchain. Use timestamps and use a cryptographic signature that's published and publicly available. Even if the company disappears, everything there, all the chains of evidence, are still available, and they can still be validated 20, 30 years from now. When you use DocuSign to sign documents now, anybody heard of DocuSign? It's a very common way of signing contracts these days. DocuSign verifies your signature, but doesn't keep a record, an independent attestation of what was actually signed and when and by whom. They're just simply certifying that someone who claimed to be you signed this thing. And so this is a kind of service you can value add. You can say this will be verifiable 20 years from now. And that's the business model. That's the idea behind this cloud thing. As I've mentioned before, I feel like I'm constantly stumbling into interesting cloud projects. And that was just one that has been wandering around for a while. And it's tied into this idea that you should sign your code. We're having a couple of little issues with that with groups, where the configuration of the CS GitHub Enterprise deployment does not allow merge commits on the web. And if you do PR requests through the web, they turn into merge commits because The merge has to actually be re-signed, which means that the organization has to enable it for everyone. They can't do it on a per repo basis or even on a per organization basis. But you can do it from the command line. Because when you do it from the command line, it uses your key to sign the merge. The web doesn't use your key because it doesn't have your private key. So that was an interesting learning opportunity, because then I'm talking to the person in CS there who said, why are you having students sign the code? And so I sent the response. I said, number one, this is in fact common practice for people who are now working on open source projects. You're attesting that this is your work, and you're taking responsibility for it. So it's a personal responsibility side of this. It also means that when there are challenges to the provenance of specific information or the things that you've added to the code, they know where to go back to. And it's actually tied to you, as opposed to, oh, I'm sorry, my little brother did it while I was away from the computer. Well, maybe you shouldn't let your little brother have your signing key. Being able to identify who's done things and what they did is actually quite valuable. All right, so did anybody actually watch the serverless video? I did post it far in advance this time. This is testing my hypothesis that people don't watch the video because I don't post it until Sunday. This time I posted it last week. I'm going to try and get next week's posted tomorrow. So, okay, great. I have now falsified my hypothesis. My hypothesis was people don't watch it because I don't post it soon enough. And the answer is people don't watch it because people don't watch it. But you didn't tell me. Doesn't that work?
Like 48 that you
Okay, if you told me that, then I'm going to fix it. Because, I copied and pasted it from YouTube. I watched the video, I copied it, put it in there.
The optimal line is working. That first line is not working. Like you have 4 or 3.
Yeah, and that one's broken.
Yeah, the first line is working. The optimal line is.
Why is Candace not? Candace could have given me a 404 even. It could have told me this. All right, so I'm being lazy because I didn't check that one. Did you watch any of the videos? Okay. You checked the links though. Okay. Well, thank you. Now I know, and I'll have to go fix that, even though it's too late. See? There's always some. Okay, so I'll ask the question then. What's a lambda? Or a cloud function, or an Azure function? It's all the same thing, they're just different labels.
It's a server that doesn't, depending on how you configure it, start up unless you call it.
Calling it a server is pushing it. That's the reason they call it serverless. Anybody else? It's just a function. It's just a piece of code. It can be like a little Python script or a piece of JavaScript or whatever language it is that your particular service supports. Often they are used to perform very targeted, very specific tasks. Someone clicks on a form on a web page, and that turns into a put that gets sent to a Lambda function, which takes that information, processes it, puts it in a database, generates a response, and sends it back. The reason they are popular is because they have very little state associated with them. You don't pay for lambdas until you use them. They scale pretty well. There are scaling limits to them though. Have you hit scaling limits yet? AWS used to be 1,000. You had to like specially configure to go above 1,000 lambdas simultaneously. I don't know if that's the scaling limit you hit or not.
We use runtime.
Sorry?
We use runtime. They have serverless on there. It's kind of just a wrapper.
Okay. What was your scaling issue?
Well, it was pretty cheap to have them on there, but if you want like this thing here, like the warm full thing, it's like you can't have any. So
the reason that serverless isn't the perfect solution is that it has what's known as a high cold start time. So typically the way that serverless ends up being implemented is they spin up a container and they run the endpoint, the service, inside of the container. It's not the only way you can do this, it just happens to be a common implementation model. And what that means is you have to spin up a container. And that's the slow start. So it can be slow to get those going. Now they will reuse lambdas, so the first one can be slow, and then if you keep using it, it won't be as slow. But they're cheap. It's the cheapest way you can actually not use them. Because if you're not using any lambdas, you don't get any bill for it. If you have a container, the container is hot, it's ready to go, you can run your lambdas inside your own container. They won't have that lag, but now you're paying for the container because now it's warm and you're paying for that resource. So that's the trade-off. People often start with lambdas or Azure functions or Google Cloud functions. They often start with them because they're cheap. They're easy to use, they're cheap, they're just pieces of code. You've already run this code on your own local machine, you know what it's basically going to do, and it talks to a database connection that is outside of the Lambda. So the database part is persistent. So now you do have to have a database. So you're paying for the database, but that's fine. Databases are really cheap. Everybody needs one. There's lots and lots of databases to choose from. The Lambda is really just a functional unit. And it fits really well into an event-driven architecture. What did I say? Someone pushed a submit button on a form. Something happened, and we processed it. Very easy to fit into a natural workflow. You started paying for warm start. In other words, you're paying somebody to keep a container with your Lambda in it available. And that costs money. But it meant that people weren't waiting for a couple of seconds for this thing to respond because it was cold. And it promises no servers. That's the whole serverless idea. The moment you start using actual orchestration, you start using containers, then of course you're now worried about servers. Anybody, I don't use it for this class, I use it for the other class, I use Gradescope. And Gradescope is actually implemented using virtual machines and containers. So they have their own virtual machines in which they run containers, and the containers actually run the code that's being tested. But that's now a much bigger infrastructure chunk to have to manage. How many of you have actually set up a virtual machine before? You should do it. It's a good exercise. What do you get when you set up a virtual machine? Why would you set up a virtual machine?
To obfuscate dangerous links, or if what you're hosting on the virtual machine is supposed to be publicly accessible.
So the primary reason you might want a virtual machine is because you want something that is in the public internet and thus subject to constant attack. That if it gets compromised, has a very clearly defined perimeter of what can be lost or stolen. Why would you need to have something that's outside of your private network? See, there's this common thing called a webhook. Has anyone ever seen a service that requires a webhook, or built a webhook, or used a webhook? Have any of you ever used Discord? Well, there you go. You go, look, that's how Discord works. When something happens inside of a Discord server, a bot can be notified. And that is done through a webhook. But a webhook is a public-facing IP address. So literally, it is talking to a machine that you control. Now, if it's really simple, there are ways of kind of cheating and hacking this by using a proxy server. I've done that before. You use ngrok. Ngrok, not ngrok. Ngrok. Ngrok is one of the services, it's not the only one, it's one of the services I use, where ngrok gives you a public IP address and a port number on it, and you can use that to then connect your service inside of your private network to ngrok, and ngrok then forwards anything that goes to that IP address and that port number, it forwards it to your internal private service. So there's a hole in your firewall, but it's a very small hole. It's much easier to defend. But it's still a hole in your firewall, and it still has certain downsides associated with it. I use them. They're actually very useful for very low volume callback mechanisms, callback sequences. I was using it to monitor like Google services. So Google has an entire API about being told when your calendar changes, when you get email, when you access anything on Google Drive or Google Docs. All of those things are available. And you can be notified when they change and what happens, and you can deal with that. I could do that with Lambda too. But in the case of the Lambda, then what's happening is it's going to invoke the service in Azure, Google Cloud, or AWS, and it's going to have to do something with that. And what do I want it to do with that? If I'm trying to build a Discord bot, maybe I just simply pick a joke and return it. I don't know. What that serverless function does is really up to you. You get to define that. It sounds really good. You don't have to manage any servers, you only pay for what you use, and you have infinite scale. Well, infinite for some value of infinite. It does actually allow pretty good scaling, especially if you're trying to get started. But what's the catch? The first invocation is slow. It's the cold start problem. There's a vendor lock-in here. The thing that you the right to work on AWS doesn't work on Azure. You're going to have to rework it. Maybe it's not a big rework, but you're going to have to change it a little bit to meet the differences in the APIs and the interfaces and the services they provide. They are intended to be something that runs for a very short period of time. 30 seconds, 2 minutes, maybe 5 minutes, but not longer than that. You're getting billed per unit time. We're having this conversation, the two guys up front who are building a whole thing that's got speech in it, and they were talking about how one of the APIs they're using charges per minute. And I said, okay, great. Well, that's per minute or any fraction thereof. Because if you use 5 seconds, you're going to get billed for a minute. If you use 3 minutes and 5 seconds, you're going to get billed for 4 minutes. And they were trying to figure that out relative to their own billing, and I said, well, you're probably going to want to do the same thing. You're just going to round up. The moment that it goes over a minute, you round it up. The functions are inherently stateless. So if you want something to be persistent, you have to use another service from the cloud vendor. Typically, I suppose it could send an email or something, but typically you're using another service, well, that would still be a service because you're using an email service from them, to do something with that data. And they're hard to debug. I don't know if you've ever had to debug containers, but there are whole mechanisms now where you can log into containers and actually observe what's running inside of the container. It's useful because weird stuff happens and you can't see it. It's worse in Lambdas. It's worse in serverless functions. So we have to build an infrastructure for allowing you to do that, which basically means that we have to put that in a container where you can't see anybody else's Lambdas, and you'll have to pay for that. From the cloud provider's perspective, this is great. This is easy to start because it's a nice low barrier. So we get you in, we get you hooked, and then you find out that actually moving this stuff becomes more and more difficult the more you're using these things. You've already got a working pipeline. The cost of moving your database from one vendor to another vendor, or even doing cross-vendor work, that cost starts to add up pretty fast because all of the cloud providers charge for what's called egress, moving data out of the data center anywhere else. Not ingress. They don't charge you for sending data to them. They charge you for sending data out of them. Now, like in Lambdas, it's actually built in. There's the response is built in, but it's got a cap size. If you start talking to other services outside the network, you're going to have to pay for that. They have their separate APIs, so they're going to lock you in. This isn't an evil thing. It just happens to be by design. So if you're going to claim that your code is portable across vendors, you're building a cloud project where you say, we don't have vendor lock-in, then the kind of clause control test you're going to have is going to require you actually make sure that you are not locked in. Is your business logic separated out? Does it work without their SDKs? Or if it doesn't work with their SDKs, have you tested it with at least two? If you've tested it with Azure, but you haven't tested it with Google Cloud or AWS or some other cloud provider, then you don't really have portability. You have a claim of portability, but you don't sound any more convincing than an LLM does when it tells me that its code is running, even though it's never actually run the test program it just wrote. And they will do that. They do it all the time. I have a rule in my Claude.md that actually says the instance that writes the code cannot write the tests. They violate it on a regular basis, and I call them on it. They say, well, you know, you're absolutely right, but I'm sure that another instance isn't going to be able to find any bugs. You say, no, do it anyway. They go and do it, and then they're back and like, wow, the other instance found 4 bugs. And instead of having 30 tests, now you have 127. Like, well, it's not like having 127 tests is better or worse than 30. What's more important is it tested different things. If you're writing your own code, you probably will be writing your own tests. But then your discipline is you write the tests and then you write the code, and you don't change the tests to make the code work. You leave the tests alone. And of course the problem there is then you find out there's a bug in the test. And you're going to break that wall. You're going to break that wall. It's not good discipline. And if you're working in a multi-person group, then what's going to happen is one of you's going to write the tests, the other one's going to write the code. That's the right way to do it, because you bring different biases to the table. The LLMs have enough variation in them that even using the same model, and I prefer not to do that, I prefer to get a different model to do it. Even using the same model, you end up getting different tests than you would from the LLM instance that built the code in the first place. So that's why I said I don't trust them, but that doesn't mean I can't use them. I view them as being adversarial. So when you're thinking about your Capstone, how many of you are using serverless? How many of you have actually thought about the tech stack you're trying to use for the Capstone project that is now due in, what, 4 weeks? 3 weeks? Sort of. No pressure. I mean, deadline's in March, soon. Nobody? You might want to be thinking about that at this point. Just saying. How many of you still have midterms left? Alright, well, I don't know how you can call like 3/4 of the way through midterm, but people do it. And part of the goal here is that first deadline is sort of in a period when you're not supposed to be having midterms or finals. So I would suggest we think about the next 3 weeks as being the right time to focus on things. So next time, tell me what tech stack you're thinking of. What is the problem you're trying to solve, first of all, and then use that to drive your choice of tech stacks. This is the problem. Here's how I'm going to try and solve the problem. Here are the tech stacks I've identified that help me solve that problem. Here's what I'm going to do to put them together. Here's how I'm going to validate them. Here's what my goals are for this project. This is what I'm trying to accomplish. I want to come up with this really cool service that I can then leave university and go to the Shark Tank and show them this really awesome idea and get money to build my company, or whatever. I want this to be a cool open source project that I can share with the world and prove to them how really great I am. Or it's going to be a turd and I'm going to try and bury it and hope no one ever actually finds it because I don't want to support it. Those are all perfectly reasonable things along the spectrum. Just decide what it is you want to accomplish and do it. What vendor-specific APIs are you deciding on? Well, if you don't have a tech stack, you don't know that yet. That's a question you should be able to answer. Would you be able to move to a different provider? And if so, what would it take? What's it going to cost you? Again, if you're not in a tech stack spot, you don't even have answers for these questions yet. All right, and then the rest of this time is literally time for you to work on the capstone here while I'm here. I'm happy to answer questions. You can, organize your Polymarket account if you really want. I hear that Polymarket is currently betting that whoever it is that's running Cuba right now isn't going to be running Cuba much longer, which is sort of a very strange comment on humanity. But you're probably sitting there thinking, damn, I could have made Polymarket as a really cool capstone project. Right? Isn't that what's in your head? No. Why not? Anybody struggling to find a capstone yet? Still? I just threw one out. Build something that looks like Polymarket. They need a competitor. How many of you even know what Polymarket is? There's two people who were basically like stared at the screen, glued to the screen. You know what Polymarket is? Imagine a betting market where you can bet on anything. And it's all based on cryptocurrency, of course, because that kind of betting is technically illegal. So people literally are betting on what's going to happen in the war in the Middle East right now, or the war in Ukraine, or and what's kind of interesting is how you can watch it and realize that it is this leading indicator of where people think the problems are going to be next. It doesn't mean it's accurate. It's just literally, why are they talking about the leadership of Cuba next? And that's because of some comment that someone made day before yesterday suggesting that that might be the next target that Donald Trump wants. But it's a cloud project. Why? Because it's all built on cloud technologies. It's a betting pool. It's a betting market. Yeah, it's using blockchain. Well, blockchain is a cloud technology. It's going to have an interface. It's going to have some sort of display to show you what's trending and what you're voting on or what you're betting on and whatnot, and what your account balance is. Perfectly reasonable kind of cloud project to build. And frankly, it doesn't have to be Polymarket. It can be almost anything. Fake stock portfolios. That is what you really want to do is help the big butchering outfits in Southeast Asia. There's a lot of money in showing fake portfolios online. Do I think it's ethical? No, not personally, but somebody will pay for it anyway. All right, I'll be around. I answer questions if you have them. But last week I walked around and I talked to everybody. This time I'm going to let you guys talk to me if you need something or if you want. Otherwise, I'm just going to sit here and stare at it. Maybe I'll go talk to Claude.